Write the following quadratic functions in standard form. Write down the coordinates of the vertex and x and y intercepts for each of these examples. I'll start with example 1. Y is equal to 2x squared minus 12x plus 14. To put this in standard form means to put this into the form y is equal to a x minus h to the power of 2 plus k. As you can see, in the standard form there is no linear term anymore. There is only a quadratic term involving x. To do this, there is a procedure that I will follow for all the three examples. Focus on the first two terms which involve x. Factor the coefficient of x squared. If I factor 2, I will have x squared minus 12 divided by 2x, and then I have a 14 outside the bracket. I can simplify inside the bracket to get 2 times x squared minus 6x plus 14. Now let's look at the coefficient of x. It is minus 6. Divide the coefficient of x, which is minus 6, by 2 and you would get minus 3. Now square minus 3 and you would get plus 9. Add a 9 and subtract a 9 inside the bracket. Because I added a 9 and subtracted a 9, the total does not change. But now the new form gives me the advantage of considering the first three terms together to turn them into a complete square. The complete square would be x minus 3. This minus 3 is what we had over here, to the power of 2. If you're not sure, you can go backwards. You can expand x minus 3 squared and make sure you can get x squared minus 6x plus 9. There is also a minus 9 that I carry down, and there is a 14. Now let's open the first bracket. I multiply 2 into the first term and then into the second term. I will have 2 times x minus 3 squared and then 2 times minus 9, which is minus 18, plus 14. I can simplify this further to 2 times x minus 3 squared minus 4. Now to write down the coordinates of the vertex. You note that vertex is either the maximum or minimum of the quadratic function. In this case, it is going to be the minimum. Now, look at what number makes the quadratic term disappear. That is x equal to 3. Because then you would have 3 minus 3, which is 0 squared, giving you 0. For this value of x, y becomes minus 4. These are the coordinates of the vertex. So I will write vertex has the coordinates 3 and minus 4. To find the y-intercept, put x equal to 0. It is easiest to put x equals 0 in the general form, the form that we started with. Then we will have y is equal to 2 times 0 squared minus 12 times 0 plus 14, which is 14. This is the y-intercept. To find the x-intercept, put y equal to 0 and solve. To do this, it is better to use the standard form. We would have y equal to 0, implying that 2 times x minus 3 squared minus 4 is equal to 0. To isolate x, take minus 4 to the other side. You would have 2 times x minus 3 squared is equal to 4. Divide both sides by 2 and you would have x minus 3 squared is equal to 2. Now take the root from both sides of this equation. You will have x minus 3 is equal to plus or minus root 2. And that means that x is 3 plus root 2 or 3 minus root 2. These are the x-intercepts. Let's now look at the second example. The second example says y is equal to minus 3x squared plus 6x minus 4. To put this into standard form, I look at the first two terms and I factor the coefficient of x squared. I would get minus 3 times x squared plus 6 over minus 3x and then minus 4. We can simplify this further by noting that 6 divided by minus 3 is minus 2. Now let's look at the coefficient of x. It is minus 2. Divide this coefficient by 2, you would get minus 1. And square the result, you would get plus 1. Inside the bracket, beside minus 2x, add a plus 1, which you found here, and subtract it. And you have minus 4 at the end. Now the first three terms inside the bracket can be combined to give you a complete square. The complete square is x minus 1 squared. The minus 1 is what you found at this stage. And then we have a minus 1 and minus 4. Now let's open the first bracket. We will have minus 3 x minus 1 squared plus 3 minus 4. And this is equal to minus 3 x minus 1 squared minus 1. To find the coordinates of the vertex, look for the number which will make the square equal to 0. That is x equal 1. And then if you put 1 into the expression, minus 3 0 squared will give you 0 and you will be left with minus 1 for y. This would be the vertex, which in this case is the maximum of your quadratic function. To find the y-intercept, put x equal to 0 in the general form. You can also use the other form, but the general form is easier. Y becomes minus 3 0 squared plus 6 times 0 minus 4, which is minus 4. That's the y-intercept. And to find the x-intercept, put y equal to 0 and solve for x. Let's now put y equal to 0. It is easier to use the standard form. Y is equal to minus 3 x minus 1 squared minus 1. If you put it equal to 0, you can see that minus 3 x minus 1 squared minus 1 is equal to 0. Now take minus 1 to the other side and you would have minus 3 x minus 1 squared is plus 1. And divide both sides by minus 3. You would have x minus 1 squared is 1 divided by minus 3, which is minus 1/3. Right at this point, I realized that there are no solutions to this equation. X minus 1 squared, no matter what x you use, is going to be a positive number, and it can never equal minus 1/3. I will write there are no solutions for this equation, and as a result there are no X-intercepts. Let's now look at the third example. Y is equal to minus 0.2 x squared plus 0.8 x minus 0.3. I factor the coefficient of x squared from the first two terms. I would have minus 0.2 times x squared plus 0.8 over minus 0.2 x and minus 0.3 outside the bracket. We can simplify this further by realizing that 0.8 divided by minus 0.2 is minus 4 times x and minus 0.3 outside the bracket. Now let's look at the coefficient of x. It is minus 4. Divide that by 2 and you get minus 2. Square the result and you get plus 4. Add and subtract plus 4 from inside the bracket. You would have minus 0.2 x squared minus 4x plus 4 and minus 4 and minus 0.3. The first three terms give you a complete square. That is x minus 2 squared. Minus 2 is what you found here. You also have a minus 4 and then minus 0.3. Now multiply minus 0.2 into the first bracket. You will have minus 0.2 x minus 2 squared plus 0.2 times 4, minus times minus is plus, and then minus 0.3. This is minus 0.2 x minus 2 squared plus 0.8 minus 0.3, and that is 0.5. This is the quadratic function in standard form. To read off the vertex of this equation, we try to find the value of x which would make the quadratic term 0. The quadratic term is x minus 2 squared. 2 would make x minus 2 equal to 0. That is the x coordinate of the vertex. If we plug in that value into this equation, the standard form, the first term will vanish and we're left with 0.5, which is the y coordinate of the vertex. To find the y-intercept, we put x equal to 0. It is easiest to use the general form. In the general form, y was minus 0.2 x squared plus 0.8 x minus 0.3. If we put x equal to 0, we see that y is equal to minus 0.3, and this is the y-intercept. To find the x-intercept, we put y equal to 0 and solve for x. Let's do that over here. We better use the standard form. Y becomes minus 0.2 x minus 2 squared plus 0.5, which becomes 0. Therefore, here is the quadratic equation we have. If we had used the general form, which is this one, we would have to use the quadratic formula now to find the values of x. But using the standard form, there is an easier way to find the values of x in this equation. Take 0.5 to the other side in order to isolate x. We would be left with minus 0.2 x minus 2 squared on the left hand side and minus 0.5 on the right hand side. divide both sides by minus 0.2. You would have x minus 2 squared is equal to minus 0.5 divided by minus 0.2. The right hand side is equal to 5 over 2 or 2.5. I leave it as 5 over 2. It's a positive number. We now take the square root of both sides of this equation. We find that x minus 2 is plus or minus root 5 by 2. We move minus 2 to the other side and we find that the x-intercepts are 2 plus root 5 2 and 2 minus root 5 over 2.